Hi, I'm going to walk you through one of the key measures of dispersion in statistics called the standard deviation. And here's this very intimidating formula for what standard deviation is. But let's walk through it, and I think we'll find it's not nearly as intimidating as it looks. So let's make up three test scores, an 80, an 85, and a 90. And we're going to need to know what the average is, so we can come up here to Excel and hit the function key, say tell us the average. It's going to ask us for a range. We want that range, and not surprisingly the average is an 85. All right, now one of the standard deviation, the key measure of dispersion is we're trying to figure out how far away from the average, or the mean, which is this X bar, stands for the mean, how far away from the mean are our scores, or how dispersed are they? So, not surprisingly, all we have to do is take the difference between each test score and the average, or the mean, right? And I'm going to lock in Excel, remember our lock keys, our dollar signs. And now I can fill this down, and because I have very few, I'm just going to add these up. All right. So I get a dispersion of 0. Well, wait a minute. It doesn't make sense. Obviously, I can't have a deviation of 0 because that would mean all my test scores were identical. So obviously, we're doing something wrong. Well, what are we doing wrong? Well, we're taking each test score, subtracting it from the mean, and adding them all up. And what's happening, if you think about it, not too surprisingly, is our negative numbers and our positive numbers are negating each other. So, of course, if we take all of our test scores, compare them to the average, and add them all up, we're going to get right back to the average, or 0. So, to compensate for that, what the formula does is squares each one of these numbers, right? Because what happens when I square a number, if you remember your math, if I take each number and I square it, it turns negatives into positive, because a negative times a negative is a positive, right? So now what I've done, if I sum them all up, now I actually have a positive number, because notice the negative 5 has become a positive number, and now I've got something here. Okay. Now the next thing I want to do is, obviously if I had 100 test scores, I'd have my summation would be much larger. So what I want is the average deviation. So I take my sample size minus 1, which is 2, right? And now average, I just take my 50 divided by my sample size minus 1 to make this an average deviation, so to speak. Now, I have an average deviation, how far I'm deviated from the mean, but remember I squared all these numbers, right? So someplace in here I got to unsquare them, which is this guy, the square root. So now I can take this number, take the square root, or raise to the 1/2 power, and I have 5 as the standard deviation. Now, we've sort of walked through why this, at least to me, makes a lot of sense. I take each test score, compare it to the mean, square it to make it positive, sum them all up, divide by my sample size minus 1 to get an average deviation, and then take the square root of that number. Now, lucky for you, you don't have to go through all of this, because Excel, if you go to the functions and you go to statistical functions and you come down here and you go to standard deviation S for a sample, it's P for a population, but we're doing with a sample. It says tell me the numbers, and I say okay, and whoa, I get 5. Hope this helps. It's a measure of dispersion. It helps us describe our data, how far away from the mean our data is. Thanks.